Alrighty, in this video what we're going to do is we are going to take a look at how we can pass data from our client, objects from our client, all the way down the component hierarchy to whatever components request that data. We do this through something called context. Now, context is a feature of React that in the documentation, they are not entirely sure if they're going to keep the API the way it is, but it is incredibly useful. It is used by a lot of libraries, including React Router, in order to pass information down to subcomponents. To put simply, a context allows us to pass data down a component hierarchy without having to pass props explicitly. Let's say you have three components, A, B, and C, and they each are in the hierarchy. So A is at the top, B is rendered by A, C is rendered by B. Now let's say A has some data that you want to pass down to C, but you don't want to pass it for whatever reason through B as a prop. What you can do is you can declare that the top level A component has a context, and it can provide that data, and then the C component can pick up on that data. Now, contexts are generally considered to be bad practice for most use cases. Most use cases, you should absolutely pass props down. But in the case of doing something like using Redux or React Router or the architecture that I'm using here, you really need to have some infrastructure in place in order to access the stores and the services from within our container components without introducing global variables or other nasty hacks. And contexts, as long as they're hidden, they provide a great deal of power and flexibility for your infrastructure code. So, how do you use context? Well, let's start off by creating a new folder called lib. And what I'm going to do is I'm going to create a context provider. Think of it as the class that's going to provide a context to all of its children and all of its children's children, and so on, all the way down the hierarchy. We create a new file called component.js. And in this file, I am going to go ahead and I'm going to import React and children and prop types from React. Then I'm going to export a class called storeProvider that will inherit from component. Now, whoops, did I not? I did children. Why did I do children? I should have done component. I said component, didn't I? I don't know. Stuff and things. You know what I mean. So for the store provider, it's a component, and I'm going to force it to. I'm going to have it force you to provide properties into the store provider. The store provider is going to provide the services and the stores to any container component, just like how the router provides itself as well as its history to any container component as well. So if we come up here, I'm going to say static prop types equals object, and I'm going to say stores is prop types dot object dot is required. And then I'm going to say services is prop types dot object is required. Then I'm going to write a render method that will simply return. Actually, I do need children, don't I? I'm gonna ask for a helper called children from React, and I'm going to say return children.only this props children. And what children.only does is it's a helper function from React, and what it does is says it will return, if you pass an array of React elements, it'll go and it will make sure that there's only one. There's not zero, there's not more than one, there's just one child. And if there's more than one children, it'll throw an exception. So the children of whatever we wrap store provider around will be rendered out here. But we should only ever pass in one child, because render only accepts returning a single child. That's why we do children only. Now, before we delve into contexts, let's go ahead and see how we'll use the store provider. So jumping back into client.js, up here at the top, I'm going to, I'm actually going to move that there. And then after we import actions, I'm going to say import store provider from /lib/component. Then, just like how we wrap our router around our routes, I'm going to go ahead and I'm going to wrap the store provider around the router. So I'm going to say store provider. And then, of course, I'm going to start getting an error now, because if I come over here and refresh, we'll get an error that we're not passing in our prop types, our proper prop types into the store provider component. So let's make sure we pass in stores equals stores and services equals services. Come over here and do a refresh. The only warnings we should be getting is ESLint yelling at us for not using some stuff. So yeah, that's how we're going to use the store provider. Now, how do we have the store provider provide those stores and services to all of its descendants? Well, what we need to do is do two things. The first thing is we need to add another static property. And this static property is called child context types. And it's actually going to be the same thing as our prop types. We're going to do stores and services. It doesn't necessarily need to be the same thing as our prop types, but it just so happens that the only thing this component does is it exposes its properties down into the grandchildren. Now, this only declares to React that we have context types. That's it. It doesn't actually provide the context objects. To do that, we need to add a special method down here underneath render, or above it, doesn't matter, called getChildContext, which will return our stores and our services. So I'm going to extract those out first from our props. So stores, services equals this.props. And then I'm going to simply return stores and services. And that's it. Now, actually, we don't need React here, so just to get ESLint to stop yelling at us, I'll remove that import. Now, anything wrapped in a store provider anywhere in the hierarchy can ask React, hey, I want this item from the context. See, by default, this doesn't do anything. The subcomponent has to request that it gets a piece of this context before it'll be available to it. Let's go ahead and see how that looks. However, I don't want you to follow along right now. I'm just going to show you guys how we would access the context from a Grandchild component. So let's go into components. Let's open up lobby. And what we have to do is we simply have to declare to React that we want a piece of the context. And we do that through a static property. So I'm going to say static context types. Now this is context types. Remember, child context types declares what this component provides to its grandchildren. Context types declares what this component wants from its grandparent. So what we'll say is, we'll simply say, I don't know, stores : react.proptypes.object.is required. Now I can save this out. And now, inside of my render method, I'm simply going to say console log this.context.stores. So all I did was I declared that I wanted this piece of the context, and now I can say this.context followed by that name. So if I reload, we should see a console log out somewhere, and we see it right here. Lobby.js, which is this code right here that we just wrote with the console log, has printed out all of the stores. They are now being accessed by the context. We can even open up the React developer tools and look at it. So if we look at store provider, or if we go into like router context, app container, and go into the lobby container, we see that it is getting a context of stores. So remember, gotta do three things. On the grandparent component, well, four things, or no, just three. On the grandparent component, you have to declare to React what prop types you want to expose as your context. Then you actually have to provide that, the actual things, that the objects that constitute those variables. They have to line up. These names are important here. And then the last thing is, you just got to declare that you want a piece of that context, and that's it. But I don't want to have to declare that I need these context types on all of my container components. So I'm simply going to use inheritance to create a base container component class that will automatically grab the context types and provide other helpful helper methods that we'll use down the road. So let's go ahead and delete this out. Oh, obviously, hopefully you guys weren't following along. That was just a demonstration. Let's jump back into component and let's create a base class that's going to be used for all of our containers. And all that base class is going to do is it's going to access the context. So I'm going to say export class container base extends component. Then I'm going to say static context types equals stores prop types dot object dot is required and services prop types dot object dot is required. Then that's really about it. Now we can access the stores through our context through any class that inherits from container base. But I'm going to add a couple other things. Again, this is just in light of the fact that I want to get sort of our infrastructure code out of the way, even though we won't be using some of this stuff quite yet. But all the container bases are going to need to be able to subscribe to reactive extension observables. All right, so our stores are going to be publishing all of the state changes that happen in observables, and our components, our containers, need to subscribe to them. However, once those containers are unmounted, we want to automatically unsubscribe. So what I'm going to do is I'm going to provide a little bit of a helper function inside of this container base. We'll start off with the constructor. So I'm going to do constructor props, super props, just like always. And then what I'm going to do is I'm going to say this underscore dispose functions equals array. Then I'm going to provide a subscribe function, which is going to take in an observable, which I'll denote with money, and a callback. And what I'm going to do here is I'm going to say const sub equals observable dot subscribe callback. Then I'm going to say this underscore dispose functions push function, which will simply invoke sub.unsubscribe. So every time we subscribe to something, we'll subscribe to it properly, the observable, but then we'll have on our dispose functions a new function that will unsubscribe from that previous subscription. Then I'm going to say component will unmount. This means the component is done. It is no longer a part of the hierarchy. It's been destroyed. Let's say you went from the lobby and then you went to a game. You want to unsubscribe from the lobby store once you do that. So I'm going to say this dot dispose functions for each d goes into invoke d. Now that invocation is important, and that'll simply invoke this function for every subscription, which will invoke the unsubscribe function from React.js, which will, not surprisingly, unsubscribe. Then, to be clean, I'm going to say this dispose functions equals new array. Then I'm going to provide two more helpers. I'm going to provide a dispatch action helper. The dispatch action helper will say this.context.services.dispatcher.emit action. Then I'm also going to provide a request helper, which will be this context services dispatcher.request action. And so these two helpers will allow us to dispatch things without having to do this context services dispatcher all the time. And that's basically our container base. There's not any more to it. Just a couple helpers, and it gets the context, it gets the stores and the services. Now, I want to point out there's another way to do this. It still uses context, and this is the way that Redux works. Redux will actually, instead of you inheriting from a different base class, you wrap your entire component, your component class, around a function called connect. And invoking connect will create an entirely new component that kind of wraps around your component. It's called a higher order component. It's a very cool technique. But I really struggled with whether I was going to do it that way or this way. This way is more object-oriented. It reduces the amount of clutter in your React hierarchy. It's, in my opinion, a little bit easier to understand and explain, and it also allows us to put helper functions onto the components themselves. The drawbacks of doing it this way is if you ever inherit from this class and have a component will unmount callback, be sure to call super.component will unmount. Also, if you have different context types that you want to use, you'll have to copy these values out of the container base. Let's take a look at that. Let's go and let's hook up our container base to our lobby and to our game. So I'm going to go into lobby, and up here at the top, I'm actually going to remove this import for component. And instead I'm going to say import container base from /stores container. Pretty sure, component, derp. Component. And then I'm going to inherit it with lobby container. And I'm going to scroll down here to lobby sidebar, do the same thing. All right, all I did was change what we're inheriting from. Then inside of game, I'm going to do the same thing. Just copy that import. And then come up here, paste this below React, and it doesn't matter either way. We'll no longer have a component, and we'll go ahead and inherit from container base. Now, there should not be any change visually. Let's go ahead and verify that. I'm going to come here and refresh, go to console. And stores, lib. Can't believe I missed that. You guys probably caught that. But yeah, make sure that you're importing from lib component. Now, there shouldn't be any visual difference, like I was saying, or functional difference. However, we should be able to go into the React Dev Tools and go into our, let's say, our lobby sidebar, and we see that context has the stores and the services attached to it. So now the lobby sidebar has access to our model, has access to the observables from our stores, and has access to dispatch actions with the dispatcher. Now, let's say that in our lobby container, I wanted to add in some context types. Maybe I wanted access to the router from React Router, but I didn't want to access it through props. I would come in here and I would have to, instead of saying static context types equals router react.proptypes.object is required, this will work, but you'll see that it'll override the other context types that are prototypally inherited from the previous class that we inherited from, as you can see right here. Now the only thing we're getting is the router. This router is, like I said, provided by the router component up here. So bear in mind, if you want to access additional context, be sure to copy container base context types first. So use the object rest spread operator. And now if we reload, we will see that our, come on, there you go. Now that we reload, we see that our lobby container has our stores, our services, and our router in its context. But yeah, we're not going to do that here because we just need to inherit from container base and we will get access to our model. So that is how we hook things up. Now remember, with the exception of one area, which is a little bit iffy that I had to really think about, the primary containers are going to be the lobby container, lobby sidebar, game container, and game sidebar. Generally speaking, you want as few container components as possible, and you want them to be very small and just depend on other components passing in the data they receive from the model down the line, so that things like the chat component can stay very simple and reusable and useful. So it's important to understand that container base with a lot of power comes a lot of responsibility. Don't misuse it. And with that, that concludes our context, and we will see you guys in the next video.